This is going to be an example where we have a special case, and we're going to end up with two solutions. There are actually two triangles that can be formed given these exact measures. I've only drawn one of those possible triangles. This is probably, this is not an accurate drawing of that triangle, but I'm just drawing this out so you can see what kind of triangle we have. So if I take a look at the information that I have labeled, in a consecutive order, I have a side, and an angle. So this is an SSA triangle, and hopefully you remember that a little bit from geometry. Now, when you are dealing with information that gives you an SSA triangle, this is when you kind of have to be on high alert. You are possibly going to have one of three cases. The first case being that there is one solution, just like the previous example. We solved one triangle, and that was it. It was very straightforward. The second possibility is that you actually have no triangle that exists. It's a no solution case. And then the third case is where you have two possible solutions. You're actually solving for two triangles that technically exist with these measures. And that's the kind of example that we're going to see here. So this is going to be a pretty long one because, like I said, there are going to be two triangles that are getting solved. All right, so let's go ahead and make a chart. So because I know that this is an SSA triangle, I'm going to go ahead and just prepare myself for the possibility of two triangles. Now, I just told you that there are going to be two triangles, but normally you wouldn't know in the very beginning. All right, so you can go ahead and set yourself up just in case. What I'm going to do is I'm going to go ahead and just write down my A, B, and C, and then my little a, B, and C for the sides. And in the case there is a second triangle, hint, hint, there is, I'm going to go ahead and write down A, B, and C again for that second triangle. All right, so I can go ahead and plug in the given information. That's going to stay the same. So side A is 12 in both of them. That won't change. Side B is 31, and angle A is 20.5. All right, so let's go ahead and start solving what we can. So I see here immediately I have one complete set. So the next piece of information that I'm going to be able to solve for is this angle right here. I can't solve anything for C yet because I can only be missing one piece of information, and here I'm missing both. So let's go ahead, and since we're solving for angle B, I'm going to go ahead and do sine of B in the numerator. I'm going to use the reciprocated version of the formula. So sine B over side B, which is 31. And then I'm going to do the same thing in the same order. I'm going to use my complete set. I'm going to do sine of the angle, which is 20.5 over 12. All right, so here, what we're going to do on both sides is we're going to multiply by 31. And when you multiply by 31 on both sides, these will cancel. So we're going to be left with sine of B. And if we plug all of this into the calculator, all right, we're going to get approximately, I'm just going to round, 0.9047. All right, but remember that I'm just looking for angle B, not sine of B. So we're going to use our inverses, sine inverse of sine B, and we're going to do that on both sides. Now, to get the most accurate answer, make sure that you're copying this entire value into your calculator. So we know that those signs will cancel out, and we get B is approximately, and when we plug in sine inverse of this entire decimal, right, just copy and paste that from your calculator, we're going to get 64.8 degrees. All right, so I'm going to go ahead and plug that in for B, 64.8 degrees. All right, I'm going to go ahead and I'm going to keep solving, but what we're going to do is I'm just going to star this really quickly because we're going to use that later on. That was the first angle that we solved for, And that's going to be really important in the next step. That's the first one that we solved for. All right, let's go ahead and keep solving. So here, to get angle C, I can just do 180, and I can subtract 20.5 minus 64.8, right? So I'm going to do 180 minus 20.5 minus 64.8, and I get 94.7 degrees for my third angle. 94.7 degrees. So now we can go ahead and set up the next part, which is going to give us side C. Alright, so I'm going to put side C in the numerator over sine of this. And this is one case where I cannot avoid using a rounded value. I ended up rounding 64.8, which gave me a rounded answer here as well, but I can't avoid it. So I'm just going to have to use that information here. And I'm going to set that equal to this complete set, the A's and not the B's, because the A's are more exact. So I'm going to put my side over sine of the angle. Alright, so I'm going to multiply by sine of 94.7 on both sides. I don't really have any space here, but I'm going to go ahead and write it on this side. And I know that it would have canceled out here. So for side C, if I plug that into the calculator, I have 12 divided by sine of 20.5. And then I'm going to multiply by sine of 94.7. And I get approximately 34.2. So that solves the first triangle. Now we have to check and see if a second triangle even exists. Sometimes this would be the end, right? This could be a problem where there's only one answer. Well, I'm going to show you why this problem has two answers. So remember that first angle that we found, all right? If you want to star it, it's always going to be the angle of the missing piece of information. So what I'm going to do is just go back to some basics of trig. I'm going to use all students take calc. Now, we are using the law of sines. So we have to think about the way that sine works. Here, when I had sine of some angle equals 0.9047, sine of this angle is a positive value. Well, sine is positive right here, but it's also positive in the second quadrant. And so when I solve this, I got angle B equals 64.8, which is a quadrant 1 angle. But it's also quite possible that there could have been a quadrant 2 angle, right? So what I'm going to do is the following. I'm going to use this angle as a reference angle, right? So I'm going to say that alpha is 64.8. All right, and what I'm going to do is I'm going to go 64.8 degrees into quadrant 2, right? So I'm technically doing 180 minus 64.8. All right, so let's see what that gives us in the calculator. 180 minus 64.8. Whoops, I'm sorry. That equals 115.2 degrees. So what I'm going to do is I'm going to just temporarily place that value right here. That's the second possible angle value for B, but I have to see if that's actually something that's possible. Oops, I'm sorry, you couldn't see that. I just plugged it in right here. We know that a triangle has 180 degrees, so if I do 180 minus 20.5, which was the given angle, minus the other possibility for B, which is 115.2, if I end up with some angle measure that C could be, then I have a second triangle. If I end up with something over 180, then it's not possible for there to be a second triangle. So let's see what we get. We get 44.3 degrees. So basically there are enough degrees to make that third angle when B is the other possibility for that, which we figured out by doing 180 minus the first angle, right, which we called our reference angle. So now that we know that a second triangle does exist, because all of this does add up to exactly 180, we're going to have to find that new side for C. All right, so we're just going to use law of sines one last time. but we're only going to use the second triangle's information. All right, so I'm looking for side C. So I have C in my numerator, and that's going to go over sine of 44.3. Disregard this right now. We're dealing with triangle 2. So sine of 44.3. And let's go ahead and set that equal to a complete set, which would be the a's. So I'm going to have 12 side in the numerator, since that's what I'm solving for, over sine of 20.5. Alright, so let's go ahead and just solve that now. I'm going to multiply by sine of 44.3 on both sides. And again, I don't have space, but if I did, those would cancel. And I get C equals, and in the calculator, I can just do 12 divided by sine of 20.5, enter, times sine of 44.3, and I get C is approximately 23.9. 23.9. Alright, so I have my final answer. There are two possible triangles, and that's my final answer.